Welcome to Sweet Statistics by Ashley and Dani. Today we will be talking about standard deviation using some of our favorite candies. Hey, I heard that standard deviation is one of the most important things that you can learn in college. Do you have any idea why?
I hadn't thought about that before. Isn't standard deviation a measure of variability?
Yeah, the standard deviation is one way of describing how much variability there is in a sample of data. More precisely, it is the average distance of all the data points away from the center of the sample.
The center of the sample?
Yeah, you need to know the mean or average of the sample first, because that is the center of your sample. Then you can figure out how spread out the other data points are. That's what variability means. If the average distance is small, that means all the points are clustered near this center.
Oh, I get it. So if the standard deviation is really large, then that means the points are really spread out.
Exactly.
Oh, I never really thought about what standard deviation meant. I just thought I need to know how to calculate it. Now that I know that it's the average distance from the mean, it helps me understand the formula for standard deviation better.
What do you mean?
Here, take a look at the formula. Here it shows that the distances between each data point and the mean are averaged. See how they're all summed up and divided by, roughly, the number of data points?
Oh yeah, I see that. I guess it makes sense. The mean is the average data point, so we sum up all the data points, but the standard deviation is the average distance, so we sum up all the distances. But wait, it doesn't look exactly like you are dividing by the number of data points. It looks like you are subtracting 1 from n. Why do we do that?
Well, that's sort of a long story. This all goes back to the difference between a population and a sample. See, we really want to know about the center and spread of populations, but that data is really difficult to gather.
Oh, so that's why you use data from samples? Are we trying to guess what the population might be like based on what the sample is like?
That's the general idea of inferential statistics.
But isn't there a problem? What if you get a weird sample, one that doesn't represent the population? A sample is not always a perfect reflection of a population, especially if the sample is too small.
Yeah, that's exactly the problem. Whenever we get a sample, we can only estimate what the population is like. This N-1 business is all an effort to try and get a decent estimate of the population standard deviation when you only have sample data.
Whoa, so you mean that just dividing by n-1 helps us estimate the population standard deviation?
Yeah.
That's amazing. How is that possible?
Basically, dividing by n-1 gives you a slightly bigger standard deviation than if you just divided by n.
Yeah, so what? Why do you want a slightly bigger standard deviation?
Well, the standard deviation computed from a sample tends to be smaller than the standard deviation of a population.
Whoa, really? Always smaller?
Yeah, you can even make up a population, take samples, and try it yourself. The only exception is when the sample mean happens to be the same as the population mean. You see, we're always trying to calculate the average distance from the population mean. That's the true center of the population data. Unfortunately, we don't know that number either.
So the standard deviation we calculate from the sample mean is too small, eh? So we want to make it slightly larger.
Yes, so we divide the sum of squared deviations by a slightly smaller number to make the estimated variance slightly larger.
And standard deviation is just the square root of the variance, right? So since the variance is slightly larger, so is the standard deviation.
Yes, with this corrected estimate, the standard deviation is closer to the true population standard deviation. It's not that you magically guessed the population standard deviation, but you did correct your estimate for being systematically too small.
Oh, so it's sort of like when you're shooting a gun and you're always off to the left. If you aim a little more to the right, you're more likely to be correct. You won't necessarily hit the target, but you corrected for your systematic error.
Yeah, that's the idea.
So if I know the population's mean and standard deviation, I don't need to divide by n-1?
Yeah, but in most situations with real data, you don't get to know the population parameters.
All of this doesn't really answer my main question. What is the point of even knowing the standard deviation?
Well, I guess I can see that it's nice to know the mean because it's a good representative of the data set. It's a 1-point best prediction of an individual score. But sometimes just knowing the mean isn't good enough.
Yeah, that's true. Just because a class's average test score is 85% doesn't mean that a lot of people got B's. After all, if the scores are spread out a lot, then maybe a bunch of people got A's and a bunch of people got C's. But if the scores are all bunched together, then it means that a lot of people in the class got B's.
I guess it's pretty useful to know the variability of a set of data in addition to knowing the average score. Standard deviation is the most widely used measure of variability in data, and it's often reported in the news or in polls.
Oh, really? I didn't realize that. I guess if I want to really understand data in the real world, standard deviation can help out. I hope I remember all of this even after the test so that I can use it in my life.